Okay, question 5. We know that modulus of n equals 5, so that means either n equals 5 or n equals minus 5. And we want to find the greatest value of 2n minus 3. So if n equals plus 5, 2n minus 3, or modulus, that would equal 2 times 5 minus 3 modulus, so that would be 7. If n equals minus 5, we'll get 2 times minus 5 minus 3, and that would equal, well, before you do the modulus, that would be minus 13, and so the modulus of that would equal plus 13. So this is going to be the maximum, plus 13. Where it says justify your answer, I think we have justified it enough. You could say 13 is greater than 7, but I think as long as you show you're working out here and here, that's fine. For part B, we want to sketch the graph of y equals modulus of x plus 3. So if you draw the axes, draw the axes over here, nice and big. Then let's draw those in red. Then the graph of modulus of x, if we draw that first in a different color, let's draw that in, say, let's draw that in this grey color here. So the graph of modulus of x looks a bit like that. That's not great, actually. Let's try and make it a bit better. So the graph of, that'll do. That's the graph of y equals modulus of x. And the graph of modulus of x plus 3 is just that graph translated up 3. So if we move this graph up 3 units, it's going to look something like this. So really should use a ruler for this, but I think you get the idea. That would be plus 3 there. If we were to sketch the graph of y equals, so if we look at this, we've already sketched the graph of this. If we sketch the graph of y equals x plus 3 all modulus, if we do that in a different color, let's do it this color, y equals modulus of x plus 3. That is this graph over here being moved to the left 3 units. So if we sketch that, it will go here. This graph would also have this. It would also go through plus 3 on the y-axis. If you put x equals 0, you'll get y equals 3. The same as you would for this graph. So it's going to go through at minus 3 here, and it's going to go through at plus 3 here. The gradient is also going to be plus 1. So it's going to go through 3, and it's going to have the same gradient as the previous graph. And then on this side, the gradient is going to be minus 1. So again, it's going to be parallel to the graph up here that we drew. Okay, so this green graph, we'll just put an arrow here. So the green graph is x plus 3 all modulus, and the blue graph is the modulus of x plus 3. So the question says, why is the blue graph always greater? Show that the blue graph is always greater than the green graph or equal to it? Well, you can see from our sketches here that when x is less than 0, let's do this in black. So when x is less than 0, you can see that this graph here, you can see that modulus of x plus 3 is always greater than the other graph, which is modulus of x plus 3 or modulus. And you can see over here, when x is greater than 0, it doesn't matter, you could put equal to 0 here, it's going to be the same. When x is greater than or equal to 0, the x values, you can see the two graphs are the same. So modulus of x plus 3 equals modulus of x plus 3. And so therefore we can conclude that modulus of x plus 3 is always either greater than or equal to x plus 3. So in terms of explanation, getting the sketches right on the graph is the most important thing here. And I think we've done enough from our graphs to explain why this would be true.